Good morning, children. Welcome back to the science class. In the previous session, we have gone through the comparison between metals and non-metals based on their physical properties. And at the end of the session, we have learned about some of the chemical properties of metals. So, in today's session, we are going to continue with the chemical properties of metals. So let's continue with the topic. Children, you already know that metals combined with oxygen form metallic oxides. So metals when combined with oxygen, they form metallic oxides. So today we are going to start our session with a type of oxide that has some special properties, and they are known as amphoteric oxides. So what are they? Amphoteric oxides. Some of the metallic oxides like aluminum oxide and zinc oxide show both acidic and basic properties. You know what are acidic properties and what are basic properties. These metallic oxides are called amphoteric oxides. So, amphoteric oxides are the metallic oxides which show both acidic and basic properties. Here we can see an example, that is aluminum oxide. Aluminum oxide, when combined with hydrochloric acid, it forms aluminum chloride and water. Aluminum oxide, when combined with hydrochloric acid, it forms aluminum chloride and water. Aluminum oxide is a basic oxide. It acts as a basic oxide and it combines with an acid, forms salt and water. You know, when an acid combines with a base, it forms a salt and water. Here, aluminum chloride is the salt formed by aluminum oxide. Now let's see. If the same aluminum oxide combines with sodium hydroxide. Sodium hydroxide is a base. So when this aluminum oxide combines with sodium hydroxide, it forms sodium aluminate and water. Sodium aluminate is again a salt. So here in this reaction, aluminum oxide acts as an acidic oxide. An acidic oxide combined with base, that is sodium hydroxide, forms salt and water. So in these two examples, we have seen that the same metallic oxide, that is aluminum oxide, can act as an acidic oxide as well as a basic oxide. It forms a salt along with water. So such oxides are called amphoteric oxides. Now, let us continue with the chemical reactions of metals. So in the previous class, we have learned the action of metals with water and dilute acids. Now let's see what's the action of a metal with hydrogen. Metals react with hydrogen, forms metal hydrides. So metals react with hydrogen, forms metal hydrides. All the metals, do they react and form metal hydrides? No. All the metals cannot react with the hydrogen. Some of the metals like sodium, potassium, calcium, magnesium, which are very highly reactive metals, they combine with hydrogen and form the corresponding hydrides. So sodium when combines with hydrogen, it forms sodium hydride. Or magnesium combines with hydrogen, forming magnesium hydride. So metals when combined with hydrogen forms metallic hydrides. Now let's see what is the action of a metal with halogen. You know halogens. Which are the halogens? The elements like chlorine, fluorine, etc. They are called what? Halogens. So when a metal combines with a halogen, it forms metallic halides. When a metal combines with halogen, it forms metallic halides. So here an example we can see. When sodium combines with fluorine, it forms sodium fluoride. Sodium combines with fluorine, it forms sodium fluoride. When sodium combines with the chlorine, it forms sodium chloride. Understood, children? Now, let's see what is the reaction of metals with steam. The reaction of metals with steam can be classified into different groups. That is, metals. There are highly reactive metals, moderately reactive metals, and less reactive metals. So some of the metals which are moderately reactive combines with steam. Steam is nothing but the gaseous stage of water. So these metals combined with steam produce metallic oxides with the liberation of hydrogen. And these metals, when react with steam, they glow brightly. They exhibit a bright glow. So moderately reactive metals react with steam, produce metallic oxides along with the liberation of hydrogen. And what about the less reactive metals? Metals like iron, aluminium, and zinc react with steam and produce metal oxides and hydrogen gas. Again, there's no difference in the products. Even less reactive metals react with steam, produce metallic oxides and hydrogen gas. Then what is the difference? Here, the reaction, as a result of this reaction, they will not give a glow, bright glow. That is the difference. So for example, zinc react with water, that is steam, produce zinc oxides and hydrogen. Then iron react with steam only when iron is red hot and it produces a mixture of ferric oxide and ferrous oxide and hydrogen gas. So what is the specialty of iron? Iron react with the steam only when the iron is red hot. Means it is highly heated to a very high temperature. If it is heated to a very high temperature, then only iron react with the steam and it produces a mixed product of ferric oxide and ferrous oxide. You know, iron can produce two types of oxides, that is ferrous oxide and ferric oxide. So you can see that iron when combines with steam, if it wants to combine with steam, what is the condition required? The iron should be heated to a very high temperature. Means it should be a red hot iron. What about the metals like gold, silver, copper, etc.? The metals like gold, silver, lead and copper, they don't show any reaction with steam. That means they do not react with steam. So what is the action of metals with steam? The action of metals with steam varies according to their reactivity. You know the reactivity series. So according to the variation in their reactivity, they react with the steam. And some of the metals do not react with the steam. Let's see what is the action of metals with nitric acid. In the previous session, we have learned the action of metals with hydrochloric acid. Now let's see what is the action of metals with the nitric acids. When metals react with nitric acid, there is no production of hydrogen gas. So when metals react with the hydrochloric acid, they form a corresponding chloride with the liberation of hydrogen. But when metals react with nitric acid, hydrogen gas is not evolved. What's the reason for that? That is, nitric acid is a strong oxidizing agent. You have studied already in your 9th standard that nitric acid is a strong oxidizing agent. It oxidizes hydrogen into water. So the hydrogen what is formed during this reaction is converted into water by the nitric acid as it is a strong oxidizing agent. And the nitric acid itself undergoes reduction to give various oxides of nitrogen. So, when nitric acid reacts with metals, instead of releasing hydrogen, releases water because nitric acid is a strong oxidizing agent. Oxidizing agent is a substance which can provide oxygen during a chemical reaction. So, the hydrogen released during the chemical reaction will be oxidized by nitric acid and form water. And the products, the nitrogen products, that is produced by the nitric acid, like nitrous oxide, nitric oxide, nitrogen dioxide. That is a type depends on the concentration of acid. So it varies. If the concentration is more or less or moderate, the nitrogen products formed will vary. Let's see an example. When copper reacts with nitric acid, that is concentrated nitric acid. When copper reacts with concentrated nitric acid, it forms copper nitrate along with water and nitrogen dioxide. Copper nitrate, water and nitrogen dioxide. And if copper reacts with dilute nitric acid, it forms copper nitrate plus water plus nitrous oxide. So based on the concentration of nitric acid, the products formed varies. But the nitrate and water is produced in all the reactions. Only the nitrogen products will vary. Nitrogen oxides will vary according to the concentration of the acid. And you know that metals like gold and silver, they do not react with any acids. Metals like gold and silver, they do not react with any acids. Here also, they are not, they don't have any reaction with the nitric acid. We have already learned that the gold, silver and platinum, these metals do not dissolve in any of the liquids, even in acids. So we have already seen that. Now, are these metals inert? No, we cannot say these metals are inert metals because there is a liquid in which this metal can dissolve, and that liquid is known as aqua regia. So let's see what is aqua regia. A solution of hydrochloric acid and nitric acid in the ratio 3:1 is known as aqua regia, and this liquid is a highly corrosive fuming mixture, and this mixture can dissolve gold and platinum. So aqua regia is the mixture which can dissolve gold, silver and platinum. So if you take 3 ml of hydrochloric acid and mix it with 1 ml of nitric acid, we get a fuming mixture, and that is known as what? Aqua regia. Aqua regia. Now, let us see what is the action of metals with salt solutions. So when metals react with various salt solutions, the more reactive metal displaces the less reactive metal from its solution. When metals react with salt solutions, the more reactive metals displace the less reactive metal from its solution. You know, salt solution means metallic salts. It's a solution, okay? Not sodium chloride salt. When an iron stripe is dipped in copper sulfate solution, copper gets displaced by iron. When an iron stripe is dipped in copper sulfate solution, copper gets displaced by iron because iron is highly reactive than copper. You know, in the reactivity series, iron is above copper. When the reaction starts, the blue color of copper sulfate solution fades and turns pale green due to the formation of ferrous sulfate. So, when an iron nail is dipped in copper sulfate solution, the blue color of the copper sulfate solution changes into greenish due to the formation of ferrous sulfate, because the copper gets deposited as reddish brown residue on iron stripe as the iron displaces copper from the copper sulfate solution. So we can represent it as CuSO4 plus Fe gives FeSO4 plus Cu. FeSO4 is nothing but ferrous sulfate or iron sulfate. So, what happens if a copper stripe is dipped in iron sulfate solution? Now we have learned what happens when an iron stripe is dipped in a copper sulfate solution. If you do the vice versa, what will happen? When a copper stripe is dipped in iron sulfate solution, no color change occur as copper is less reactive than iron. As there is no reaction taking place, no color change we can see. So keep in mind, only when we dip an iron piece in copper sulfate solution, the color of the copper sulfate solution will change and it will become greenish. But if we dip a copper stripe piece in iron sulfate solution, no color change can be observed as the copper cannot displace iron from its solution. Understood, children? Now, let's see what's the reaction of non-metals. So the previous class and even today's class, we discussed about the action of metals with different situations, that is with water, steam, acids, oxygen, etc. And now let's continue this with the action of non-metals with these substances. Okay. So first let us see what is the action of a non-metal with oxygen. We have already learned that metals when react with oxygen, they form metallic oxides. Non-metals react with oxygen forming their oxides, which are acidic or neutral in nature. So, non-metals when react with oxygen, they form oxides which are acidic. Metals when react with oxygen, they form oxides which are basic. And even we have seen about amphoteric oxides, the metallic oxides which can act as both as an acidic oxide and a basic oxide. But non-metals when react with oxygen, the oxides which are formed are acidic or neutral in nature. For example, carbon when combines with oxygen, it forms carbon dioxide or carbon monoxide. Carbon when combines with oxygen, it can form carbon monoxide or carbon dioxide. If the amount of oxygen is more, it forms carbon dioxide. amount of oxygen is less, it can form carbon monoxide. Both this carbon monoxide and carbon dioxide are acidic oxides. Now, the second reaction, that is action of non-metal with halogens. We have seen that metals, when react with halogens, they form their halides. Here, non-metals react with halogens, form corresponding halides. No difference. How the metals react with the halogens to form halides. Even non-metals react with the halogens, form their halides. For example, carbon, when react with chlorine, it forms carbon tetrachloride. You already know about the carbon tetrachloride, which you have studied in hydrocarbon chapter. You know how it is formed and what is its molecular formula. And phosphorus, when react with chlorine, it forms phosphorus pentachloride. So when a non-metal react with halogen, it forms corresponding halides. Now, what's the action of a non-metal with hydrogen? Non-metals react with hydrogen, forms their hydrides. Non-metals react with hydrogen, forms their hydrides. For example, here we can take sulfur. Sulfur reacts with hydrogen, forms hydrogen sulfide. And we have seen the action of metals with water. Now let's see what is the action of non-metals with water. Non-metals have no action with water or steam. So we have already seen that some of the metals react with the cold water, some other metals react with the hot water, and yet other metals react with steam. But non-metals do not have any action with water or steam. Understood, children? So now we went through the topics, that is the chemical reactions of metals and non-metals. I hope you understood. So let's continue in the next session. Thank you.